Heat and its effect. What is heat? The experiments conducted by Count Rumford and James Prescott in the beginning of the 19th century established that heat is a form of energy known as thermal energy. Many other forms of energy can be converted to heat energy, and heat energy can be converted to other forms of energy. For example, when you rub your hands together, mechanically, energy gets converted to heat energy and your hands become warm. When fuel is burned, chemical energy stored in the fuel gets converted to heat energy. In an electric heater, electrical energy is converted to heat energy. When a solid, liquid, or a gas is heated, its molecules gain energy and start moving faster. The more we heat the substance, the faster its molecules move. Heat energy is therefore the energy of movement of molecules. Effect of heat. When we heat a substance, the movement of its molecules increases. This increases the average distance between the molecules. Therefore, the space occupied by the molecules, that is, the volume of the substance, increases. We say that heat causes expansion. Expansion in solids. Solids expand on heating. We can take the following experiment to show expansion in solids. Take the ring and ball apparatus. This apparatus consists of a metal ring and a metal ball. At normal temperature, the ball just passes through the ring. Now heat the ball and try to pass it through the ring. It will not pass through. The ball has expanded on heating. Cool the ball to normal temperature, it will pass through the ring. Expansion in liquids. The molecules of a liquid are not so firmly bound to each other as in a solid. Therefore, on heating, their vibration increase more than the vibrations of molecules of solids. The result is that liquids expand more than solid on heating. Expansion in liquids experiment. To see the expansion in liquids, see the following activity. Fill a flask up to the brim with water. Take a rubber cork with a hole in it and insert a narrow tube into the hole. Fix the cork firmly in the mouth of the flask. The liquid will rise a little in the tube. Note the level of the liquid. Heat the liquid. You will notice that the level of the liquid in the tube goes down initially as the flask gets heated first and expands. When the heat reaches the liquid, it expands and its level in the tube goes up. Cool the liquid to normal temperature. The level will go down again. The amount of expansion is different in different liquids for the same increase in temperature. Expansion in gases. On heating a gas, the vibrations of its molecules increases. Since the molecules are not bound to each other at all, the average distance between the molecules increases considerably. Hence, the expansion will be more in case of gases than in liquids or solids. Thus, gases expand more than liquids and solids on being heated. Expansion in gases experiment. To see the expansion in gases, see the following activity. Fill a flask up to the brim with water. Fix the flask to a stand-in and upside-down position over a beaker of water so that the glass tube dips inside the water. Heat the flask at the top. As the air in the flask expands, it escapes out of the flask through the tube into the beaker containing water. Bubbles of air can be seen in the water. Cool the flask. As the air inside the flask contracts, the water rises up the tube. This shows that gas like air expands on heating and contracts on cooling. Expansion in gases experiment. To see the expansion in gases, see the following activity. Fill a flask up to the brim with water. Fix the flask to a stand-in and upside-down position over a beaker of water so that the glass tube dips inside the water. Heat the flask at the top. As the air in the flask expands, it escapes out of the flask through the tube into the beaker containing water. Bubbles of air can be seen in the water. Cool the flask. As the air inside the flask contracts, the water rises up the tube. This shows that gas like air expands on heating and contracts on cooling. The another example expansion around us are railway tracks. The railway tracks over which trains run are made of iron. During summer, the iron expands. To allow this expansion, space has to be left between two sections of the rail tracks. If this is not done, expansion of the tracks can cause them to bend. This can cause serious accidents. Temperature. Why did the bottle of water feel cold in the fridge while it was so hot outside? The answer lies in the concept of temperature. Temperature indicates the degree of hotness or coldness of a body or a place. We must remember that our own sense of what is hot and what is cold can sometimes be misleading. So, you see, the terms hot and cold are only relative terms. There always has to be a reference body with respect to which we can say whether a given body is hot or cold. Therefore, it is important that we use an instrument rather than our own judgment to measure temperature. When you touch a hot object, you feel hot. If you touch a cold object, you feel cold. You feel hot in the first case because heat energy flows from the hot object to your hand. In the second case, as heat energy flows from your hand to the cold object, you feel cold. How to measure temperature? We can use either the Celsius or the Fahrenheit scale to measure temperature. The Celsius scale. Temperature on this scale is measured in degrees Celsius, read as degrees Celsius. On this scale, we take the temperature at which pure water freezes at sea level to be 0 degrees Celsius. This is called the lower fixed point. The temperature at which pure water boils at sea level is called the upper fixed point. It is taken as 100 degrees Celsius. We say at sea level because the temperature at which water freezes or boils changes as we go to higher altitude. The Fahrenheit scale. Temperature is also measured in Fahrenheit. Its lower fixed point is taken as 32 degree Fahrenheit and the upper fixed point as 212 degree Fahrenheit. In our country and in most other countries, the Celsius scale is more commonly used. Conversion formula for degree Celsius and degree Fahrenheit. The simple equations given below will help us to convert one temperature scale to another. Number 1 is Fahrenheit equals to Celsius into 9 upon 5 plus 32. And second one is Celsius equals to 5 upon 9 Fahrenheit minus 32, where F is for Fahrenheit and C is for Celsius. Measurement of temperature. The instrument used to measure temperature is called thermometer. There are 4 different types of thermometer. Mercury thermometer. In 1714, Gabriel Fahrenheit invented the first mercury thermometer. Mercury is used in thermometers because of the following reasons. Mercury remains in the liquid state for a wide range of temperature. It melts at minus 38.87 degrees Celsius and boils only at 356.58 degrees Celsius. It is relatively easy to see because of its silvery grey color. It does not stick to glass. It has a fairly uniform rate of expansion for an inside range of temperatures. Alcohol thermometer. Thermometers in which alcohol is used have some advantage over mercury thermometers. Alcohol is cheaper and less harmful than mercury. Alcohol thermometers can measure much lower temperatures than mercury. However, the main disadvantage of using an alcohol thermometer is that these thermometers can measure temperature only up to 78 degrees Celsius, while mercury thermometers can measure much higher temperatures. Laboratory thermometer. It consists of a thin glass tube which is sealed at one end and has a bulb at the other end. The range of temperature which a laboratory thermometer can measure is from minus 10 degrees Celsius to 110 degrees Celsius. Clinical thermometer. The thermometer used to measure our body temperature is called a clinical thermometer. It is generally a mercury thermometer, though nowadays digital thermometers are becoming very popular. So in this section, we learnt about the heat and its effect on solid, liquid, and gas. We also learnt about the temperature and measurement of temperature.